Hi YouTube, this is Joe Calton with Calton Cutlery. I've got a very exciting knife to share with you fellas today. Um, I've got a 6-inch wabocho out of differentially hardened 1095. Um, this one right here, I was grinding a batch of knives, and this one, the grind was fighting me. I think it was probably the first one I did, and I ended up breaking the spine really hard when I was grinding the bevels in. Now normally breaking the spine doesn't, if I break it a little bit, that doesn't bother me very much. As thin as I grind kitchen knives, um, breaking the spine, heck, that just means I'm getting thin enough. This one though, what I ended up doing was I ended up breaking it really hard, like half of the width of the blade. Right about there you can see. No real excuse for it, just early in the morning, you grind, that's what happens. But the exciting thing is that, when you screw up a regular knife, why then, as long as it's not an order, why then you get a test knife out of it. So what I did on this blade was I decided to test the handle. I do an awful lot of tests on the blades all the time, but I wanted to test the handle. So, as an aside, breaking the spine that hard, I ended up using that a couple of months later after I messed this one up, and I did it on purpose on a Nakiri. The customer wanted a very, very, very thin Nakiri, and on these hidden tang handles, I have to make them out of 3/32 inch stock because that's the smallest mill bit that I have to be able to cut the guard. Normally on hunting knives and stuff, they're a little bit thicker. I cut the guards by hand, but on this 3/32 inch stock, it's too thin. I can't get my files in there to cut the guard slots, so I do them on the lathe. But anyway, that was just a nice little aside there. Anyway, so what I did was I went ahead and I finished out the handle, or basically stopped grinding once I noticed where I was at, and then stuck a handle on it, sharpened it up, and threw it in my kitchen. I used it for 2 or 3 weeks, something like that, and then I stuck it in a dishwasher. Everybody tells you not to stick high carbon steel knives into the dishwasher, so I did it. Stuck it in there and I left it in the dishwasher for a month. Now, we run the dishwasher probably once every other day or so, so for 30 days it went through at least 15 cycles, and I never took it out, just left it in there the whole time. Now here in Wyoming we're kind of very dry. There's not a whole lot of humidity in the air, so the level of rust and discoloration on this blade would be an awful lot different in a place that had an awful lot more humidity. The really surprising thing was that there wasn't a whole lot of damage running it through the dishwasher. I mean, this is like I said, 1095 high carbon steel. I've got a micarta guard, and then I just use regular old walnut for a handle, and then a single 1/8 inch brass pin. Now the handle does look extremely dry. I finished this one out like I do with all of them, with just a mineral oil. Just dip the handle in mineral oil before I ship them out, and you can see the difference in between. See how dry that wood looks? But about the only damage that the handle took that we can see so far is that it just dried the wood out a little bit. Right after I pulled it out of that last cycle, the handle had swollen up 10 thousandths or so, and it was proud over the guard. Now it's down to about 2 thousandths or so, being left in a dry environment in the shop for the last month or so. But anyways, I'll set it down so you can kind of see without the light glaring in your face about how much discoloration there is. There is some rust. Like I said, I didn't wipe it down, I didn't do nothing. I just stuck it in the dishwasher and left it sit in there. It's got a really rough finish because after I realized that I'd messed up the grind, I didn't want to put a whole lot more time into it. There is some more rust. Let the camera focus there, up around the junction between the blade and the guard, and some more around the tip. I left it in the dishwasher point down in the little basket that you put your silverware in. I don't know if that makes any difference in the test that we're going to do, but what we're going to do at the end of the video is break the handle off and then examine the tang and see how much rust we got and how much rust made it past the handle epoxy. My favorite handle epoxy is G-Flex. This stuff is some really tough epoxy. It's got just a hint of give, so it'll take an awful lot more shock than other epoxies will. But being it's a test knife, I want to, see as much as I can out of it. So this blade, 6-inch wabocho, 6-inch tip to the guard, 10 5/8 inch overall, 1 3/4 inch wide. The grind is 43 thousandths at the spine, 23 thousandths 1/4 inch back from the edge, and 17 thousandths thick at the shoulder of the edge. As an aside, that was also pretty surprising. When I took this into the kitchen, I figured it was going to cut like crap because the edge was so thick at the shoulder of the edge, 17 thousandths. That's twice as thick as what I normally grind kitchen knives down to. But that measurement, 1/4 inch behind the edge, was at 23 thousandths, and it actually did really, really good, and kind of started leading me to believe that the measurement at the shoulder of the edge is important, and the measurement at the spine is important, but that measurement 1/4 inch back from the edge, it's probably more important than the other two measurements. See, went over the other stuff. I did a rope cutting test on my heavy manila rope. The first cut was 13 pounds. I was feeling kind of heavy-handed today. The 200th cut was 20 pounds, so a difference in 7 pounds worth of force over 200 cuts, which is pretty good, not bad. It did 10 edge flexes over my 1/4 inch brass rod on each side, and there was no chipping, no rolling, nothing unexpected there, so that did really nice. We're going to go ahead and do a flex test in the vise. Probably going to flex it to, well, let's see. The hardening line is about like this. About like that. So we're going to clamp it up to, say, about there or so. See what it does in a flex test. I stuck a towel behind my vise and moved the vise over at a little bit better angle, so maybe you can see a little bit better how much flex there is when and if it breaks. Got some leather in my jaws of my vise. Okay, we're clamped up to about that line. Got safety glasses on. Let's make sure you can see it. Yep. Okay, so let's do the first 90. There's 190. And a lot of times you'll see them, once you let go of the pressure, it'll come back up, and then if you just sit there and watch it, it'll actually keep straightening out on its own. I can see just a little bit of it right there. But anyways, see if I can flex it back over the other side. I don't usually like to flex blades towards me like that, so I want to keep my body out of the way. So there's 90 on that side. Yeah, you can see it there starting to straighten up on its own some more. So that's 180-degree flex. There's 90 on that side. These thinner blades are much easier to make to where they'll pass the 90-degree flex tests. much easier to make a blade that's thinner pass a 90-degree flex test than it is a thicker blade. So now 90 the other way maybe. Now see, it's almost a shame to have to break a knife that's doing this well, but I gotta see how that tang looks. So anyway, so there's 280-degree flexes. We'll kind of straighten it up there a little bit. Yeah, that's close enough. And you can see that the edge isn't cracked. Passed 280-degree flexes and didn't do anything to it. So now the exciting part. Bring you over to the anvil. Now like I said, this is just a plain walnut handle. Nothing real special about it. But that G-Flex epoxy has treated me really well on knife handles. Now we got a 3-pound cross peen hammer that I picked up the other day. Okay, so we got it split. And the rest of that isn't wanting to come off yet. Now you can see how good this, should have been wearing gloves there. You can see how good this epoxy is. See how that wood is just embedded in there? The wood will give way before this epoxy will. And my surface prep, if I remember on this one, I wanted to see how important the surface prep was for this epoxy. And even with kind of lousy surface prep, it's still holding on there pretty good. So now let's get rid of that micarta. That'll be a little bit tougher. Just shattered. Aha. Okay. This is what I wanted to see. Skip. Alright. So that part right there was where the epoxy was inside the guard. We've got a little bit of rust up to it, but none past it. And you can see that I left the fire scale on here before I glued it up. That was part of my what I wanted to see how well the epoxy was going to bond to it, and it bonded kind of okay, but I'd much rather put a 60 grit finish on that. You see on this side we might have had a little bit of leakage down past it, but really I think with a good 60 grit finish on there, that'd give the epoxy something to grab a hold of. I don't think we'd have any leakage problem at all. Right there you can really see a nice line where the rust came in and was stopped by that epoxy. Here we might have had a little bit of bubble. There was a pinhole in the fit up on this guard, so that could be that there wasn't enough epoxy in there and it was able to slip past it. We'll talk about an exciting test. That lets me know that that G-Flex works really well as a handle sealer. Lets me know I should probably wear gloves when I'm doing these beating handles off. And that was a nice knife. Hope you enjoyed it.